Berg Knows Theory podcast.
All right, everybody, welcome to the Berg Theory podcast, where we discuss AI and how you can actually use it. Our goal is to ensure that you, our listener, have the tools, knowledge, and understanding to leverage AI to simplify and automate areas of your life or business. So on today's episode, we are going to talk about OpenAI, with the root question being, what is OpenAI and what do they actually do? As we know, OpenAI was founded in 2015 by the likes of Sam Altman, Elon Musk, Greg Brockman, Ilya Sutskever, a number of others. And they started as, initially, and I think still to this day, they are technically a nonprofit that was and is devoted to the study, the education, the advocacy, the commercialization of AI. I guess research and development plugs in there too, research and development of AI. But what does OpenAI actually do? And, day to day, what are their products? How do we use them? All of the above. We're going to dive into that. So let's get started. Harry, what is OpenAI and what do they do?
Yes, what do they do? So just kind of frame things firstly, what I really want to talk about today is the product side of things. Basically, it's not just ChatGPT, but it's other stuff, and that is powering a lot of the AI advances that you see across all of your favorite products. Most of them are even, boasting on their landing page now, powered by OpenAI. So how do they actually do that? I don't really, I feel like there's probably better resources out there to talk about, the structure of the company and the history and that kind of thing. But I can definitely talk to the products and what's out there right now. So the starting point would be, of course, we all know ChatGPT. That is the flagship product. And if you haven't used it, it's a conversational chat interface which you can interact with via text, just like you would text back and forth with another person, or in the sense that it's a chat interface, text-based chat interface, or you can use it by voice now as well, which is a much more natural mode of interaction, which the bet is from OpenAI that that's going to catch on, and more people are going to want to have that chat interface. But ChatGPT is just a product. ChatGPT is not the AI. The AI behind ChatGPT is GPT. So ChatGPT is a product powered by the AI system GPT. We've discussed GPT before. GPT is an acronym that stands for Generative Pre-trained Transformer, and that's a specific type of neural network, which is the AI model that powers deep learning, which powers machine learning, which is an approach to AI, which is an approach to automation. So that GPT part, that's the digital brain of the system. And ChatGPT is basically a product, a nice graphical user interface wrapped around that AI model, which can predict response from prompt. And so under the hood, what's really happening, the core of OpenAI's product is that they have wrapped an API around a very powerful AI model. So I think we've mentioned very briefly what APIs are, and it's one of those terms that's thrown around all over the place, and everybody claims to have an API. But just to recap and give people a simple definition of what is an API, the simplest way to think about it is a piece of code running somewhere which knows how to listen for certain types of requests and returns certain types of responses depending on how that piece of software is programmed to work. So in this case, the API is a piece of software which listens for requests such as, here's my prompt, and the software which OpenAI have written know to listen for that type of request, to put it through this large language model, to predict what the AI system's, what GPT's response would be to that, and then send that back to you as the response. So that's what the OpenAI API does. That's the technical thing running the whole of ChatGPT. Again, ChatGPT is this pretty user interface which wraps around that very complicated system. And just to kind of differentiate between what is AI, what is API here, I'll give another example of maybe two more examples of APIs. So, basically every big company has an API. And most products that we use, almost every product we use actually, is just a graphical user interface wrapped around an API. That is a pretty front end which talks to an API on the back end. So for example, the YouTube API is what your browser is sending messages to when you click buttons around YouTube. The YouTube API can listen for things like, get me a list of whatever shorts I should show on the feed next, or, it listens for requests to upload a video. It listens for requests when you say, like this video or add it to my playlist. And for each of those things, it knows how to respond. It responds with some data. In a lot of cases, that data will just be thumbs up, it worked, okay message, or in other words, a 200 status code. So APIs return these status codes whenever something goes wrong or right. The most obvious one that we're all familiar with is a 404 status code. That's when the web page could not be found or resource not found. Then there are status codes for everything. But most of the time, you hit the like button on YouTube and you just get basically a 200 back. No data comes back. But other times you might get a bunch of data back. So you might say, you might make a request to get my recommended videos for the next video. In that case, you get sent back a bunch of data, which is all of those videos. So there's just another example of, YouTube's got an API, Uber has an API, and it's listening for things like, request ride, and then it's sending you back a response, which is your driver details. It's listening for things like update payment method, and it sends you back a 200 message when they've stored that in, when they've updated the payment method on their system. But again, with those examples, just to reiterate, an API is just something which listens for requests and runs some software, which is up to the developer, whatever that software does, to eventually return a response back to the user. And in OpenAI's case, it listens for responses for things like, here's your prompt, and give me back a response to that prompt. The API also does other things like listen for, requests to generate images or to transcribe audio or to do text to speech. And that is the core of OpenAI's product. It's what powers ChatGPT. Been talking for minutes now, but before I hand back to you, Ian, I just want to say one thing, which is, what does API stand for? It stands for Application Programmable Interface. And so with those examples in mind, each of those things I mentioned, OpenAI, YouTube, Uber, they are all applications. So that's the A, an API. They're all applications that you want to interact with or you want to interface with. You want to basically talk to those things. Basically, I want to talk to Uber systems. I want to talk to YouTube systems. I want to talk to OpenAI's systems. And so that's the I, it's an interface. But the way that you're actually interacting with it is that your browser or your phone runs some code which sends that message to the API and listens back and processes that response again with code. So it's the code that's running behind the scenes. And that's what the P is for, programmatic. So it's not that you're doing this graphically with the user interface, but the API is listening for messages which are being executed by code. So again, API, application programmable interface. You're talking to some applications, you want to interface with them by writing programming code. So
you
that's
can think
at the heart of what OpenAI does and most other products do.
So you can think about an API like it's a sort of a communication bridge between systems, right? Or between data points to a degree. It serves as that
beautiful way to put it. Yeah. It's a communication bridge between the service and the client, or maybe you would say the server and the client.
Right. Because it's a request and response system. So you have a requester and you have a provider, right? And there's data that's being requested and then data that's being provided. So in the context
that's exactly right. But the specific kind of jargon there that we use is server and client.
Server and client.
Kind of the server client protocol or server client. I forget what it's called, but the methodology where the client is the end user and the server is the provider, like you said.
Right. And if you think about it in human terms, it's like having a conversation with somebody. It's like if you ask somebody a question, they have the information, they provide a response, and there's that back and forth. With APIs, this happens, billions of times per second all over the world with all the data that's moving around. So
yeah, exactly.
In the context,
that's a really good analogy, actually, because you can extend the analogy further and say, the way that APIs listen for messages and respond depends on what code has been written inside that API. And much like,
Mhm.
depending on how a human listens and responds, it depends, what's inside their brain. How do they think? So that's a good
Right.
analogy there.
Right. You could think about it like if you talk to somebody who's really good at, sports history, right? And you ask them a question about sports history, they could, they'll call the response forward and they'll give you an answer because they know that answer
Hmm.
because that's effectively how they are programmed, right?
Yeah.
So you've got that. And then maybe you have a friend that's, really good at cooking and you have questions about cooking and, you ask those questions, you get those responses relevant to that individual and the sort of data set, if you will, they're either trained on or have been built to service in a way, right?
Yeah. That's
So
exactly right.
so let's think about this in the context of OpenAI. So you said, we've got this LLM that's wrapped in an API. What does that mean, and
Mhm.
how does that ultimately affect our interaction with ChatGPT or with Dolly?
Yeah. Yeah. So let's go through kind of a slow motion, journey as if we were going from the browser to OpenAI systems and back. So, I'm sitting here, I've got ChatGPT open in one tab. I type in a prompt into the box, and when I hit send, some code runs in my browser in JavaScript specifically, which makes this HTTP request. It's called. It makes a request over the internet. It basically says, "I'm going to send some information to a certain computer on the internet, which we call the host computer, which is an IP address at the end of the day, or a URL, which is mapped to an IP address, an IP address just being the location of that computer on the internet. And I'm not just going to send it to that IP address or that URL, which might be something like api.openai.com. I'm not just going to send it there, but I'm going to send it to api.openai.com / chat completion, something like that. Or if I was generating an image, it might go to api.openai.com / images / generate, something like that. So it's a combination of the address of the computer, which is that effectively website URL, which is mapped to an IP address, plus what we call the path on the end of that, which is that /image /generate. And that entire thing, the combination of the computer and which path you want to make the request to, we call an endpoint. And so very common jargon is you hear people talk about the API endpoints. And each different endpoint which exists on an API basically reflects all of the different capabilities of that API. So like I said, you might have, the /generate image /chat completion /text to speech / transcription. And all of those things would be 4 different endpoints, 4 different capabilities of this API. And for every different service, every different big company that has an API, the API would have different endpoints, which indicates that they have different capabilities. Much like, the Instagram API might have a, /get feed /like /comment / all of these kind of things. It reflects the capabilities. So when you send a prompt to OpenAI, the JavaScript code in your browser runs, it sends that prompt over the internet, and there's a piece of software running on a computer somewhere in one of OpenAI's data centers, and probably on a very big computer, and it's listening. It's listening at that certain address, at that certain path, overall at that certain endpoint. It's listening for messages, and it's receiving these messages from potentially millions of users every minute. I don't know at what rate they're receiving API requests these days, but it's receiving loads and loads of messages. Everybody's saying, "Here's my prompt. Can you process it? Here's my prompt. Can you process it?" And so, that's part of the reason why the scaling the hardware infrastructure for these big companies is a real challenge, because they're listening for all the requests in the world on, essentially on one computer. Of course, it's more sophisticated than that, and they spread them out, but effectively they're listening for everything, and they're running that through their systems. So those prompts arrive, and the API kind of ingests them. And the API, like I said, is wrapped around kind of the core software. It's up to the developers what the core software does. The API is just that thing that's listening for those messages at certain endpoints and then hands them over to the software inside. Depending on which endpoint you request, it's going to run a different piece of software. So, you might have a function written, which is the function for generating an image. You might have a function written, which is for generating the prompt response. And the API hands off the request to that function. It runs that function. At the end of the day, that function returns some data, probably your response or your generated image, and then the reverse happens, and the API takes it off of the internal software, sends it back over the internet via another HTTP request, where your computer is still listening, waiting for a response, which the code probably running in your browser or on your mobile app. In both cases, that's probably going to be JavaScript code running, is waiting for that, still waiting after it's made the request. This is potentially within less than a second of making the initial request. It's still listening, and then eventually that JavaScript code knows what to show you on your front end. So that round trip has been made. In OpenAI's case, in the middle, the software is this very large deep neural network, specifically this transformer, the T in GPT. It's this big GPT model which needs to take in your input prompt, turn that into a numerical format, pass it through this big transformer model, this big neural network, which basically just is a big mathematical calculation, spits out some other numbers which represent your output, the output response, and then turns those back into words, and then sends that piece of text, which we call a string in computer programming, back to your front end. That's kind of a fully detailed, probably excruciating detail of how the trip works.
Yeah, it's very, very complex. And frankly, it's, a little bit, it's easy to understand, but there's so many nuances to it that if you don't have years studying this stuff, it can be a little bit, difficult to fully understand. But I think conceptually it's fairly easy, especially if you understand the concept of this kind of information bridge, which is effectively what an API is, like we just discussed. And also in that APIs are what make all of this possible, right? Otherwise you'd have, your data would just kind of sit there idle without being able to interface with, other data sources, which, of course, all of these synapses is what makes the global technology system as we know it work the way it does. And
they also kind of provide these methods that make this very scalable and very secure at the same time. All of that is kind of baked into the API technology.
Right. So going back to OpenAI, ChatGPT, and all of their technologies, when you think about their API, how might that differ from an API for a very simple app? Is it the same? Is it different? Does it have more capabilities, or is it just more powerful?
Well, every API is completely different because it's an API for what that specific company does, and the nature of companies is they all do very different stuff. Most the way that you use these APIs as a developer, as a software developer, as someone who wants to build something and put on their landing page powered by OpenAI, what does that mean you need to do? It means you need to go to OpenAI documentation. I think you can literally go to platform.openai.com/docs if you want to check that out, /API-reference. If you go there, you'll see the details of the exact code you need to write, examples in Python, JavaScript, etc., of how you can write the JavaScript code or whatever it is to make the requests to their systems. So you'll see the documentation there, and in the same way as you'll see for OpenAI, you'll see documentation for Stripe, for YouTube, for Google's APIs. It's all laid out in very much the same way. And one of the key skills as not only an AI developer but as a software developer in general is being able to read that API documentation, because it lets you know how to stand on the shoulders of these giants and request their capabilities, whether it's text processing or access to your Google Calendar or whatever it is. So that's how you would use them as a developer. You'd read the docs, you'd look at the code examples, and you'd look at the description of what each endpoint is expecting in its request and what type of information it will return in the response, so that you know what to send and how to process that response. And so, all API, to answer your question, all APIs are similar in the sense that they're laid out that same way, just basically an instruction manual of where to send the information, what to send, and what you're going to get back. But they're all different in the sense that what you're going to get back is going to depend on what that company does.
Right. Right. And so, every API is programmed a little bit differently. For example, a social media API would be different than, a payment gateway API versus, a weather app API. So
Yeah.
these are each programmed uniquely depending on, what the company is doing and what kind of data they're ultimately providing to their end user, or vice versa, right? So they're customized for the business itself, and what it does, and what its use case is.
Yeah, that's exactly
You
right. The code on the inside is completely custom. The developers
Right.
can write that to do whatever they want in whatever language they want. And there are many different frameworks for building APIs. It's not like API is a programming language. You can build an API in Python, in JavaScript, in probably basically any language. But the concept of what they do is all the same. It's this interface,
Right.
this set of instructions, which is like what I'm expecting and what I'm going to give you back. It's this kind
Right.
of I think they call it this, like the skinny waist, where it's like it can do anything on the inside, and you can do anything with it when you get it back. But at the middle, there's this tight interface where you must provide these inputs, and you will get these responses back. So it's that
Right.
like egg
And
shape kind of diagram. Sorry, egg timer
right.
shape diagram.
Yeah, it allows for interoperability. It enhances efficiency, right?
Yeah.
It would be very, very difficult to scale anything without an API.
Mhm.
I mean,
Yeah.
APIs effectively enable, technology to communicate with each other all over the world every second of every single day, right?
Yeah. That's exactly right. For all of the products you know and love, whether you are writing code to interact with them or whether you're clicking buttons on TikTok, when you do that, you're sending messages to the TikTok API.
So there's a cost to APIs. I want to talk about this too, because
Yeah.
when you're engaging with an API, most people don't know that unless you live in this world of tech. But we're all engaging with APIs all the time, and there's something called an API call, which is the actual act of you requesting information from the source, and there's a cost to that. So let's
Mhm.
speak to that too, because it's not like this just happens and it's free. There's compute, which is obviously coming from data centers, which require energy and staff and all
Mhm.
sorts of
Yeah.
other expenses. So that has to be paid for somehow, and there's a cost to it. So let's talk about
Yeah.
the cost of API calls and how that, let's talk about how it might affect OpenAI, but then let's also zoom out and talk about how it, affects businesses generally.
Yeah, for sure. So, I'd imagine actually there's not too many examples that the everyday consumer experiences of consumption-based pricing. That is, you pay as you use the product. And so this consumption-based pricing is what you typically have for APIs. It's something like, for every million requests, you have to pay, a cent, something like that. And so everybody is building different apps which send these requests to OpenAI in this example, and ask them to draft your email or write this sales letter or whatever it is the product does. Every time that you want GPT 4 or 4.0 or whatever the latest model is to make a prediction, you're making a request to the API and you're paying per request. I'll look up the exact prices in a second, but it's extremely cheap, especially for OpenAI. For others, it might not be so cheap. In fact, again, just like the custom code on the inside, the price is completely custom, so developers can charge whatever they want for it. The way that they set this up is that you usually log into their product via a web console, the dashboard, and you get what you call your API keys. These are effectively your login credentials that you would not put into any interface, but you would put in your code somewhere. And they are the metaphorical keys which unlock the capabilities of the API, and that lets the service provider know who is making these requests and who to bill, and so then they'll build your payment method when at whatever interval they deem is appropriate. Yeah.
So how much, from your perspective, how much does the cost of, of API calls affect scalability? And when there's a lot of conversation around the efficiency of artificial intelligence, the compute that's required, the cost that's, incurred as a result of that. And when you look at the cost structure of this business, I mean, you think, cloud, everything's just kind of up in the cloud. But the reality of that is, all of this data is actually stored, a lot of it is stored, most of it is stored in data centers, which are, very capital intense, energy intense places.
Yeah.
All of this action, including API calls, requires the machines to do work. And that work requires, there's cost to it, which is why there's a cost to API calls, even if it's tiny. As we're getting more efficient, as data centers are scaling, we're finding ways to bring the cost down, but there's still a cost to it. So how do you think that, the function of APIs ultimately affects the capital efficiency of AI in general?
Yeah. So, you're going to need to, if you're building a product built on top of some API, you're going to need to factor this API cost into your unit economics, right? So is the user actually paying you for every time they use your service? Maybe it's like to, generate 10 images that are going to be your LinkedIn display picture that look really handsome. Are they going to pay? If they're going to pay like that, then, clearly the unit economics will probably work there, because the price of these API calls, or at least specifically in OpenAI's case, is so low that, it's I'll actually got it right here. So the price they're so low that it's going to be totally fine, but you of course need to bake it into your unit economics and make sure that it's fine. And also don't be giving users, unlimited API calls when they sign up for a 99-cent subscription, something like that. I've got the prices right here. So just for context, really quickly, to frame the rest of the conversation, the latest model, GPT-4o, it costs $5 per million tokens that you want to process. So a token, is not exactly a word, but it's roughly a word. Let me kind of get a benchmark of how many tokens in a book. Let's see if there's a good example there. Okay, so there's one quick example here I've just pulled up. It says a 500-page book is 120,000 tokens. So you could process 10 500-page books for $5. That is the low cost of these API calls. And again, that's with the fastest and most competent state-of-the-art AI model, pretty much the most sophisticated computer system which has ever existed. That is the cost. So, sometimes I'm running lectures and I say to people, yeah, we're going to use the OpenAI API. You got to put in a credit card. People are worried about it, but they struggle to spend more than a cent in that entire session, because the cost is really low. Why is that? It's because OpenAI's mission is to realize the potential of AI and distribute it to as many people as possible. And so a big, unlock there for accessibility is they need to make the price as low as possible, so that more people can access those benefits which they're realizing.
Right, and as computing power gets more efficient, I mean, you've got the NVIDIAs of the world that are working to make their chips more efficient. That will ultimately help the cost too, because we're still right now, we're of course in the early innings. We've definitely advanced a lot over the last 20 years in terms of compute, but we're still at a point in time where and there's speculation that some of the new chips that are going to be coming out are 10, 20, 100 times more efficient at processing data than what we currently have. And so like most innovations, up front, I mean, even though $5 per million tokens is not a lot, it's likely going to get cheaper and cheaper as the technology scales, i.e. more accessible.
Yeah, absolutely. I mean, it's like the cost of electricity is probably one of the bottlenecks for AI right now, just in terms of how much power these data centers consume for training, for inference, and for hosting the software which surrounds all of that. But yeah, absolutely, more advanced chips and basically in every part of the stack is going to reduce the cost even further. And hopefully that'll be passed on to us as the end users of these systems, and we'll be able to access more of these AI systems for a lower and lower cost so that we can do more crazy things with them. Because, once they're intelligent enough, I guess what we'd like is that each of us have an AI assistant which is processing, maybe everything in our surroundings. It's processing, maybe some people don't want that, but it could be processing, every electronic device in your house. It could be processing every message, every email you send. It could be transcribing your voice in real time. It could be providing, subtitles in your field of view and whatever. Like all of those things is going to take API requests. And so, there's a lot of data that we would like to be processing. So it's not the case of, it's not like it would be hard to process 5 million tokens in a day. Like that sounds like a crazy amount, but it's not like it would be hard to do that. And then there are software systems, which you alluded to earlier. A point I wanted to bring back is like, they're running all the time. They're like, there is software which can just be processing things continuously. Maybe you want to build some kind of system to buy and sell things on eBay, and in which case it's reading every single listing which is added to eBay, and then it's writing its own listings and doing that continuously. Right? It would not be hard to spend more to spend more than that $5 for those million tokens. But we'd like those kind of things to be able to exist because they'd help us to do more, help us to be able to make more money, help us to automate our businesses and delegate more of the boring parts of our lives.
We've talked about this, but it seems like the direction things are going, the big general AI models like the ChatGPTs of the world will eventually get to a point where they are more or less commoditized, where all the big tech players have developed these models, and you go from one to the next and they effectively operate in the same fashion. Do you think that we will find ourselves in a place where there's a whole world of businesses and technologies that are built on maybe just on ChatGPT or just on OpenAI's technology, and so it sort of serves as a foundational technology for an entirely new economy?
Absolutely. Yeah, absolutely. Just one quick correction though. Again, it's not on top of ChatGPT, it's on top of GPT. So ChatGPT is the product, GPT is the engine.
Sorry, GPT.
Exactly. Yeah.
Right.
And GPT will, it will be the bedrock of lots of new types of companies that exist, which are just in some way or another doing AI processing all day long. Yeah, absolutely. That'll be really interesting to see. One thing I want to squeeze in here is just a very tiny detail, which is the way that a lot of the APIs are set up. When you make these API requests, especially to OpenAI, is you specify as part of your request which model you want to use. Is you want to use GPT 3.5, 4, 4VO, or whatever. And that's just one line. So one of the really interesting and cool benefits of this kind of interface for these very powerful systems is that when OpenAI develops a new model and they release GPT-5, you only need to change one line of your code to replace GPT 4.0 with GPT-5, and then suddenly you have unlocked all of that power, which is contained within that model upgrade they've spent probably billions of dollars trying to achieve. And so it really, puts a lot of leverage in the hands of developers when their apps can take giant leaps forward in terms of intelligence with the change of just one line. Or you could even have some code which is just pulling the latest model. You don't even need to change that line yourself.
Yeah, I was thinking that while you're speaking, there probably will be a point where the advancements in these models are almost self-sufficient, where and this is where it's an incredible thing, but it's also a scary thing, to the point where these models can sort of advance themselves. They could identify, areas that can be improved, change the code, upgrade, and then take it forward with a new iteration. It'd obviously be up to the team at ChatGPT at OpenAI to enable that and ultimately take it to market and make it accessible to people. But it could happen.
Yeah. Or maybe one of us could build it.
Maybe. I'm sure. I mean, you think about it, there's going to be a lot of folks that build incredible, incredible language models that eventually will rival, the best of the best. We're still so early in the game. So
Yeah.
that's a great episode on OpenAI and some of the nuances and functions of the business, which I think in many ways applies to, some of the other, big models that are being built out there by the likes of Facebook and Google and others, or Meta,
Yeah.
I should say, and
Big
Google
time.
and
Yeah,
others.
big time. They've all
Right.
got APIs that work in the same way. Yeah.
So that's it. Well, that was a fantastic episode. I'll, as we do, leave you guys with a quote, and this is from our good friend, the Dalai Lama. Human potential is the same for all. Your feeling, I am of no value, is wrong, absolutely wrong. You are deceiving yourself. We all have the power of thought. So what are you lacking? If you have willpower, then you can do anything. It is usually said that you are your own master. And that's it for today, everybody. Thank you so much.
Love it. Cool. Thank you, guys. We'll see you next time.
The Berg Knowles Theory